That's what we know. Two sides are congruent in an isosceles triangle. Well, breaking news now, there's just not two sides congruent, there's also two angles that are congruent. Okay? An isosceles triangle has two angles that are congruent. Now, where are those angles? Depends on where the sides are. Okay? In an isosceles triangle, the two congruent angles are located across from the congruent sides. All right? So in this diagram right here, I've given you AB congruent to AC, making an isosceles. So where are the congruent angles? Across from those sides. So it would be angle B and angle C. Okay? And the reverse can be said as well. I just don't need sides. Maybe you have a diagram where two angles are congruent. So if you see at the bottom here, angle B congruent to angle C, it's isosceles because two angles are congruent. Where are the sides? Across from them. So it would be AB and AC being congruent. So the answer is it depends on where the congruent parts are. You look across from them, and there are the other congruent parts. Now, before we do some examples here, real quickly, just I know, down the hall, down here, up to the sidewalk, please. All right? I knew about that, but totally forgot.
The drill is complete. You may re-enter the building.
This person's pencil. This pencil.
That's like,
Yeah, I know. It just didn't.
no, Danny borrowed them from Tyler.
Don't.
Tyler.
Oh, God.
Yeah.
People already. Maybe you should just hit the right. I've passed this class. I more around than on this one. Trevor reaches out and choose a I think that's a fun thing to do. You don't get to sign next to
All right, let's do this. Let's get back to work. Totally forgot to stop the recording too, so gonna have a little silence. Gonna have a little silence there for about 6-7 minutes. But hey, guys, that's what fast forward's for. All right, back to where we were here. As long as I know two sides in the same triangle are congruent, the angles are opposite. I want you to get out of this mindset because this is what kids get into real quick. They always think the congruent angles are at the bottom. No, it all depends on where the congruent sides are. So is this triangle still isosceles? Yeah. Here are the congruent sides. So what are my congruent angles? D and E. Yeah. So don't just assume it's always the bottom tip. Okay. Please don't assume it's the bottom tip. Ever. All right. It's always across from the congruent sides, wherever they are. All right. So we're all good. So whether I have angles or sides, I can always look across and find the other congruent pair. All right. Going on. Here we go. Vocabulary now. Because I can't keep saying the congruent sides. The congruent sides. They have an actual name. The congruent angles, they have an actual name, and I want to start using that vocabulary when we talk to each other. First, real quick, what are my congruent angles up here? B and C. So there's one pair. There's one angle, that's the outcast, right? Maybe some of you could relate. The other angle, which is the outcast, which is he's on fire today. Angle A, okay? Angle A, the non-congruent angle. Who wants to say the non-congruent angle all the time? Not me. We have an actual name for it. Anybody know the name for it? The non-congruent angle? Begins with a V, ends in vertex. Good. Yeah, you guys are actually in honors, huh? Vertex. That's the vertex angle. Okay, vertex, the non-congruent angle. Okay. The two sides that are congruent. The two sides that are congruent. Last time we say that. From now on, we'll refer to those as, we got two of them and we walk with them. Legs. Thanks for not saying feet. And what about the unequal side? The side that's not equal to the other two in an isosceles triangle? Not a big fan of this name, base. And I'll tell you why. Because usually the middle school mentality in you says When I heard the word base, I automatically think of bottom. No, it's wherever the non-congruent side is. All right, non-congruent side is called the base. And then finally, what about the two angles that are equal to each other? The two angles that are equal. Well, let me ask you this question. What's the name of the side in between those two congruent angles? What did we just call the side in between the two congruent angles? That's the base. So those would be referred to as base angles. So let's start talking to each other with this vocabulary. All right, I got one example we'll do together, and then the other two you're going to do in your group, and then we're going to finish it up and get the books out and get going. So I have a lot of congruent marks on here, a lot of isosceles triangles in here. Huh? I think I see at least 3 isosceles triangles, right? RUV, VWS, and the big one, RTS, is isosceles. All right, what I want to know from somebody, give me another angle that's not marked, that's congruent to angle R. So please don't give me S. Give me a non-marked angle that's congruent to angle R. Because angle R is part of an isosceles triangle and it's across from these sides. Think we got it here? Angle R and angle 19.
She's not here.
Oh, first one, 22. RVU, good. Some of you guys don't see that. Let me show you. Everyone see angle R is a part of this isosceles triangle? What's across from congruent sides? Congruent angles. Yep. All right, so the Y, and this is exactly what we're going to start putting in the reasons column tomorrow when we restart proofs with isosceles triangles. Y, let's try that again. In a triangle, congruent angles are across from, you guys finish it. Congruent angles are across from congruent sides. And let me just mention something about this theorem. It does not bother me if you flip those. It's the same theorem, right? Same theorem. What's not negotiable with me is you have to have in a triangle. Why do I have to have in a triangle on there? This is the only figure where this theorem works, right? You give me, what's that, a hexagon, 6 sides? That's not true. Okay, so this only works in a triangle. That's why I have to have that statement at the beginning in a triangle. All right, let's keep moving on. RT, find something that's congruent to RT for me. Find another side that's congruent to RT. Look for an isosceles triangle that possibly contains RT and tell me the other side across from the other congruent angle. 15. I just went 2 for 3, huh? 2 out of 3. The 2 kids that aren't here today. 6.
Line
ST. How about line segment? Right? TS or ST. Everyone see the big triangle RTS is isosceles. Everyone see, hey, across from angle R is TS. Across from angle S is RT. Okay? Again, in a triangle, congruent angles are across from congruent sides. Again, I don't care if you flip-flop the angles and the sides part. I should have wrote sides. Shoot. That shouldn't be circled. Should have circled that. These can be flip-flopped. Okay. And one more. VW. Give me another side VW. It's congruent to because it's in an isosceles triangle and it's across from congruent angles. VW and 12. WS. And same thing. Hey, let's go nuts. Why don't we put sides first? Congruent sides are across from congruent angles. Any issues with this theorem? All right, I'm going to give you guys about 2-3 minutes right now. All right, I'm back. 2 to 3 minutes in your group. These two isosceles or 3 isosceles triangles. Okay, let's figure this out now. With number 1, I gave you the 55 to start with. Everyone noticed the bottom triangle was isosceles. We just learned today. Whatever's across from the congruent angles, across from the congruent sides are also congruent. So 55 degrees there. 180 in a triangle. So this x ended up being 70 degrees. All right, now I use that 70 because it's vertical with this angle here. Vertical angles are congruent. And then what do I know about the remaining 2 angles? They're congruent because they're also across from congruent sides. So I have 110 left over, right? Divide it up. Y equals 55. Yep. Any issues there? Maybe you got to them a different way, but hey, whatever gets the job done. Next one, 110. I guess you could start off by saying the supplementary angle was 70. They're linear pairs. Everyone notice the big triangle is isosceles? So x and the 70 I just wrote in are congruent. So x equals 70. And you really didn't need to know anything about isosceles to get y. 180 degrees in a triangle. Or you could have said, what type of angle is 110 again? Exterior. And what's an exterior angle equal to? The sum of the 2 remote. So 90 and y had to add up to 110. So y has to be 20. One last thing I want to show you here. Common mistake using this new theorem I've shown you today. The 2 sides have to be in the same triangle that are congruent. Here's what I get a lot of. I'll have 2 separate triangles, and I'll have 2 sides that are congruent, and then all of a sudden, oh, using that theorem he showed me, these angles are congruent. No, it doesn't work that way. The 2 congruent sides have to be located in the same triangle to use this. Everyone's good? It can't be in 2 different ones. Oh, so sad. Go start your homework. Thank you.